on Friday, January 15th, I went over went back and reviewed a few things here, but I want to talk about this since several people weren't here, and some of you may need to look back over it again to catch everything that happened. Okay, so earlier we talked about what the slope of the secant line was compared to the tangent line. And if we have 2 points like these two, we get a secant line that has a slope that runs along here. The tangent line at C right now is there, and I can move that around with this app, and we saw how that worked in class. And if I make h get smaller and smaller, h is how far these are apart, if I get it smaller and smaller, that secant line gets closer and closer to being the tangent line. And so that's the idea of what the limit is doing. It's moving this point closer so it gets a better and better approximation of the tangent line. Now they have a couple other apps in there. One is this one. And it says it's showing now a tangent line, and I can move it along on this curve. And the slope of that tangent line here looks like it's about -1. And that's what's graphed over here at 0, where at x value of 0, the slope is a -1, and so they put -1 here. And if I go over here to about there, I'm a little bit past a half. And so I'm come over to the x a little past a half, and it's saying the slope is 0. See how the slope is 0 here? And that's what's happening here. If I move over to 1, this slope turns positive and gets bigger. And over here it's saying it's clear up at 2. And it goes up off the screen if I go to here because it gets higher than 2. And so this graph, this U-shaped thing, this looks like a parabola graph, is a graph of how the slope looks on this curve over here. So what I want you to notice is this looks like a degree 3, a cubic equation. And a cubic equation, a degree 3 equation, produces a slope equation of degree 2, a parabola. That's going to be kind of something that you're going to see happen a lot coming up here. So I just want you to see that we're graphing the slope as we move along the curve, and the slope goes from positive to 0 to negative to 0 to positive. Positive real steep, a big slope, getting smaller and smaller, getting to 0. Notice the 0 was at that top point. Went down to a negative value, and that's kind of where the curvature changed from curving down to curving up. Excuse me. And then it went back to 0 slope, and then it got more positive and kept getting more and more positive. So bigger and bigger positive numbers. Okay? Then we looked at this app that they have in there, and it said we're going to plot the slope for this curve. Now here it's positive, here it's 0, here it has negative slope, and it's steep in here and gets less steep until it goes to a slope looks like about 0, and then it gets negative again. So it has a positive, negative, 0, negative, and it has some slope over here that's negative. So I'm going to trace it. I'm going to have it put a dot on the graph of what the slope is. So now I have to, where is the button? Oh, I don't see the dot. Oh, there it is. So I can follow along this curve. So now it's tracing the slope. You see how it goes to a slope of 0, then it goes negative. I skipped a little bit there. And then it goes to 0. Then the slope goes negative. And there must be some graph there. So maybe I need to zoom out. Let's see if I can do that. Oh. So there's more to the graph. Let's go the other way. Slope is 0. Slope is negative. It's 0, has positive slope. It jumps quickly there. Has negative slope. 0 slope right in there. And then it's a positive slope. 0, negative slope. 0, positive slope. And then it gets less and less. So this graph has a slope graph that looks like this. And you notice it had this cusp in here. Let's change the size. This cusp, there was no slope right there. If I go back across and show it, right there, it jumps. That's a problem when you're graphing or trying to figure out the slope. But other than that, you can see how it's following the slope, up and down, up and down, up and down. Okay? So, this makes a graph. What is the equation of this? Can we determine this equation from the equation of this or of simpler ones? And so that's what we're doing in this section. So if we take 4x minus x squared as a function, and if we went through our slope formula and worked out the slope for 0, turns out it's 4, at 1 it's 2, at 2 it's 0, 3 it's minus 2, 4 it's minus 4, and 5 it's minus 6. Now let's take a look at that. They graph it down here. It's an upside down parabola. Let's remember what that looks like. It's right here. It's an upside down parabola, and the 4x kind of shoves it over and up onto this side. Oops. So the slope is at 0, the slope is 4. At 1, the slope is 2. At 2, the slope is 0. At 3, the slope is minus 2. At 4, it's minus 4. And if we plot those points, at 0, the slope was 4, then 2, then 0, then minus 2, and minus 4. That's a line. A line is degree 1. This parabola was degree 2. So the slope function is a degree 1 when the function itself was degree 2. So they went up here and decided, well, let's just do this without deciding what point we're going to find it at. So they just used A in the formula. They went through all the stuff we've been doing in class, and they came up with this. And then when h goes to 0, this is 0. In here, the h canceled out, and we get just 4 minus 2a, which happened to be the equation of this line. 4 is the y-intercept, and it has a negative 2 slope. So with this equation, I could actually tell what the slope is for this parabola at any value. If I wanted to know the slope at 1.5, I'd put 1.5 in here and work it out. and figure out what that slope is. Okay? So the slope function for 4x minus x squared is 4 minus 2x. Now we're going to learn some tricks on how to get straight from here to here without doing all of this. But first, what we worked on in class was, all right, can you, oh, by the way, those graphs I showed you at the beginning of this video are just these apps. We're going to try to figure out what the graph of the slope of these look like, these different graphs they have here. So if you're trying to do these, you need to know how to estimate slope pretty well. So I'm going to pull up Desmos, and I'm going to draw for you a slope of 1, a slope of 2, a slope of 3, a slope of 4. So you can kind of visualize these a little bit. That steep is 4, a slope of 4, 3, 2, 1. And let's look at a half. And maybe a quarter. So there's a slope of a quarter, a half, 1, 2, 3, 4. That'll probably be enough for us to kind of be able to estimate slopes on here. So this looks like it's more than 1. 1 would go a diagonal across here. So it's more like 2 or 3. So this graph would be up here at 3, saying the slope is 3, and it decreases until it gets to here, which is 0. So it goes from 3 down to 0, and then it goes to a negative slope in here. This slope looks like about a negative 1/2 to me. So going 3 down to 0, right here it's 0, and then it goes down to maybe negative 1/2, and then it gets back to 0 here, right there, it should be 0, and then it goes back up to 3 or 4 positive slope. Positive slope, negative slope, positive slope. Positive slope, negative slope, positive slope. This kind of looks like a degree 3, and what I drew was a parabolish shape, which is degree 2. So what would the slope of this look like? Well, this is always going down, so it's got a negative slope. My question to the class was, is this slope decreasing or increasing? And some people have trouble with this. Notice that this is maybe a negative 1/2, but here it's less than that, maybe negative, or it's more than that, like negative 1/4 or negative 1/8. And so it's going from negative 1/2 closer and closer to a slope of 0. So it's starting at negative 1/2, and it's increasing, getting closer and closer to 0. So this one is curved up, or maybe just a straight line up, not really sure. Don't know if that's part of a parabola or not, but it could be a part of a parabola, and this would be a line going up. Okay. Now, from your 154 class, you should recognize this as what trig function? What kind of looks like a sine going up to pi over 2, down to pi, down to 0 at pi, down to negative 1 at 3 pi over 2, back to 0, and so on. So what's the slope right here? Well, it looks pretty close to 1, maybe a little steeper than 1. It goes to 0 there, so we'd go from a little more than 1 to 0. And then it goes to negative 1-ish in here at 2 units over. Right there, it's negative 1-ish. And then it goes to slope of 0, and then back to a slope of 1. So what curve looks like that? And so it's kind of hard to see here because we're not graphing it. So I'm going to go over here, get rid of these. And that, we thought that looked like sine x. Kind of looks like it, doesn't it? And the slope looks like it's 1. It goes to 0, goes to negative 1, goes to 0, goes to 1. Well, I think that sounds like the slope was 1, goes to a slope of 0. Right there, its slope is 0. And then it has a slope of negative 1 right here, so it plot negative 1. Then it goes to a slope of 0 here, and so the cosine curve is 0 at 3 pi over 2, and back to a slope of 1. The blue line has a slope of 1, and so there. So it looks like the cosine is the slope of the sine. We have to do some work to prove that, but that's kind of what it looks like. So what's the slope equation look like for this? Well, this slope is pretty close to 0, going to negative, to 0, going to positive 3 or 4 or something, back to 0, and then to negative, and back to 0. So it starts at 0, goes more negative, and then by here goes negative, and then it goes back to 0. Then it goes positive 3 or 4, and then back to 0. Then it goes negative some, and then it heads back to 0. So it goes okay? You like the whistle effect on that? Okay. This one looks like it has about 2, 0, up to 2, 0, up to 2. 2 to 0, up to 2, down to 0, up to 2. And I said, what would be the equation for something like this? Well, it looks like it's doing a line right there. That looks like y equal x line, if I could draw it, but I don't have the ability to draw on this particular screen. But it goes above the line, then below the line, then above the line. Well, sine goes positive and then negative. So perhaps it's the sine curve on top of the y equal x curve. Do you see how it looks like it goes up, and then it goes to 0, then it goes up and to 0? So that's kind of what this curve looks like. So what's its slope equation look like? Well, it's positive, 0. It looks like about positive 2, goes to 0, positive 2. So I'm going to go over here, and I'm going to try to draw a graph that goes from positive 2 to 0, to 0. So how am I going to do that? I think I want to do minus 2 cosine x. Cosine x. Oop. Nope, I want to turn this over. There has a positive 2, goes to 0. So the slope here was positive 2, then went to 0, so the slope equation. Then it went to positive 2, then it goes down to 0, slope is 0. So this appears to be the slope function for this. Now, we're going to figure out how to do that otherwise by using that limit definition and some other things. So what's the derivative of this look like? Well, this one is pretty simple. The slope of this is -1. Then it gets to here, and we have a cusp, and all of a sudden it jumps to +1. It stays there. So it's straight across, jumps straight across. So right here we have a problem of being able to actually take the derivative. So what's the slope function look like for this? Well, that is slope of about 1 to 0 to -1, 1 to 0 to -1, let's see, 1 to 0 to -1. Then all of a sudden it jumps to +1 to 0 to -1, jumps to +1 to 0 to -1, jumps to +1 to 0 to -1. So it's just a bunch of hash lines going that way. This looks like, to me, kind of looks like the sine of x, and someone said, with absolute value on it. And that's kind of what it looks like, doesn't it? Now, they may have changed the period in here by putting in maybe pi, or maybe not that much. Maybe it's divided by 2. And that looks pretty close to what they had in there, isn't it? And the derivative of that is not very easy to write an equation for it. Absolute value gets complicated. We're going to talk about that. All right. And finally, this one. This has a slope of almost 0 but negative, and then getting more and more negative. So it's almost 0, and then it gets more and more negative. Then this part has a slope that's very negative, very large, but in the negative direction, so very, very small, way down here negative, and then it comes up and gets closer and closer to 0. So let's look at what this is. So that is, you should recognize it. It's y equal 1 divided by x. Maybe zoomed in a little bit, but that's kind of the idea. And what I saw was something that looks like y equals, this is why you do the pre-calculus class, so you can kind of guess what that curve was. Remember, it was slightly negative, and it went to very negative, and then it was very negative, and then it came up to slightly negative. And the equation for something like that is -1 divided by x squared. So now, I want to work with this, and so I'm going to do the limit formula on this to see if we come up with that, or something like this, for the derivative function of 1 over x. So I'm going to stop this video, and then I'm going to go to writing it on paper. So the equation was y equals 1 over x, and it looks like this, and then this. And this had a negative slope that was very small, so its derivative, its slope graph would look very negative but small, and this got more and more negative. Then this was negative, very negative, and then it came up to close to 0. So I think the derivative looks something like that. My guess was it was 1 over x squared. So now let's go through the math to come up with it. So the limit formula is the limit. I'll do the h1 of f of a plus h, f of a plus h minus f of a over h. So in this case, I'm doing this one right there, so it's going to be the limit as h goes to 0 of 1 over a plus h minus 1 over a all over h. All right, now to do this, we've got subtraction of fractions, so we got to get a common denominator. So I got to multiply this one by a over a, and I have to multiply this one by a plus h over a plus h. So now, what do we have? Well, we have the limit as h goes towards 0 of I have a common denominator in the numerator of a and a plus h, and I have a minus 1a minus h, and that's over h over 1, understood there. So to get this devil up in the numerator here, I need to multiply the numerator by 1 over h and the denominator by 1 over h. It cancels that. So I got all of this out of the way. And a minus a cancels. So I have negative h divided by h, which is negative 1 over my common denominator, which is a times a plus h. Now, I got rid of that devil-y thing. It canceled out right here. So now I can put in 0 for the h, and I get minus 1 over a squared. So if a is some place on the x-axis that I'm picking and I want the slope, it says it's 1 over that value of x squared, which is what I thought it should be. This is saying the slope function, if this is the function, f of x, then this is the derivative of it, the slope function of it, sometimes called y prime. So this is the slope of that. Oh, I forgot the minus. We thought it was minus. All these are minus values, negative. So that's pretty much, that's a quick review of what I did in class today.